Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
So something real is happening, but we can't tell yet if it's a mistake in our observations, a mistake in our interpretation, or just something nature is surprising us with, such as a new kind of dark matter, a new kind of dark energy, or something else that would be really exciting to discover. So if there's a Nobel Prize in here, that could be one of them.
Take a look at this image. What you're seeing is a distant cosmic structure glowing in the early universe. However, the discovery of this luminous object has helped solve a long-standing astronomical mystery. According to our current understanding, the universe came into existence around 14 billion years ago. Following the Big Bang, it experienced a period of total darkness known as the Dark Ages, when vast clouds of gas filled the cosmos. Even with the most powerful telescope ever built, seeing beyond this era would be impossible. But for decades, scientists have been noticing that some strange light was coming from the dark clouds. A serious discovery has sparked debate among astronomers recently. For the first time, the Webb telescope observed two ancient galaxies. Intriguingly, these galaxies seem distinct from those familiar to us, prompting questions about their origin within our universe. Such discoveries of the Webb telescope have raised some big questions. Are we wrong about the age of our universe? Or are we wrong about the origin of these galaxies? What are these mysterious lights, and where do they originate? Recent discoveries from the Webb telescope have finally unraveled this mystery, suggesting that our previous understanding of the early universe may need to be reconsidered. A newly captured Webb telescope image reveals that this light is, in fact, a strong source of Lyman alpha emission. The image also indicates that galactic mergers were more frequent in the early universe than we had previously believed. We could see before the Webb telescope got going that those mergers and interactions, and the abundant star formation that they spawned, are responsible for both creating the Lyman alpha emissions. But scientists previously believed that these emissions should have been blocked by the dense hydrogen clouds that filled the space between galaxies during the Dark Ages. And we should not have seen these emissions. But we are seeing it. Well, researchers recently revealed that as stellar mass gathered and stars formed in these early galaxies, two things happened. The stars emitted Lyman alpha radiation, forming bubbles and channels of ionized hydrogen within the otherwise light-blocking neutral hydrogen gas. These openings allowed Lyman alpha emissions to pass through, demonstrating that the stars could observe objects beyond the Dark Ages. In a recent deep-field image, scientists made an unexpected discovery: two galaxies that existed beyond the darkness of the early universe. Researchers suggest that these galaxies differ from those previously observed. However, both exhibit a high redshift, raising concerns among astronomers about their classification as galaxies. This graph presents a detailed analysis of distant galaxies captured by the Webb telescope's advanced capabilities. It highlights the farthest galaxies confirmed through spectroscopic observations. Among them is GNZ11, located approximately 13.2 billion light-years away, initially identified by the Hubble telescope. The telescope has recently captured an image from the Webb, revealing something extraordinary in this galaxy. Astronomers have identified a supermassive black hole at its center, establishing it as the most distant black hole on record, forming just 400 million years after the Big Bang. This challenges our understanding of black hole formation due to its enormous size. Scientists are saying that the size of this supermassive black hole does not fit with the time period of the universe, because the death of the first stars or the merger of black holes in the early universe cannot create such a large black hole. We need a completely new way of thinking about the formation of these massive black holes so early in the universe. But wait, there's something else in this data that has shocked astronomers around the world. As we can see, these galaxies are the most distant ever discovered by the Webb telescope. The red markers indicate that spectroscopic observations have already confirmed their existence. Currently, the most distant confirmed galaxy is GZ130, which existed approximately 13.47 billion light-years away. But there's more to this data. Notice the two most distant galaxies positioned at a redshift of around 16. This suggests they existed even before the cosmic dark ages. That's surprising because, according to standard cosmological models, galaxies were expected to form at the end of the dark ages. Yet here we see massive and unusual galaxies that challenge this timeline. This discovery indicates that galaxies began forming much earlier than our theories predicted. One way we might think is that our universe may be much older than we thought, or that there is a possibility that something strange may have happened after the Big Bang that accelerated the formation of early galaxies. Well, spectroscopic observations of both these galaxies are yet to be made, but if spectroscopic observations confirm their predicted redshifts, the basic foundations of cosmology will be shattered. Well, there is another hypothesis that has recently become popular among scientists, which we know as the conformal cyclic cosmology. This cyclic universe model may explain the existence of these strange early galaxies. Nobel laureate Dr. Roger Penrose says that there was a universe before us, which he refers to as the previous eon, and that black holes evaporate at the end of the previous eon, as predicted by Stephen Hawking. The energy that evaporates from a dying black hole is believed to ignite the Big Bang of the next cosmic eon, setting the stage for a new universe. This theory also suggests that remnants of black holes from a prior universe played a crucial role in accelerating the expansion of our early cosmos. Scientists speculate that these ancient, dead black holes could be the missing link in explaining the existence of supermassive black holes and the formation of colossal galaxies in the universe's infancy. The discoveries made by the James Webb Space Telescope continue to challenge our current understanding of cosmic history, forcing us to rethink the very nature of the universe. It's hardly surprising that, within just the first 3 years of its scientific operations, the James Webb Space Telescope has shattered multiple cosmic records. Among its groundbreaking discoveries are the most distant galaxy ever observed, the farthest known protocluster of galaxies, the most remote black hole, the most distant red supergiant star, the furthest gravitational lens, and the most ancient quasar detected to date. Each of these findings is reshaping our understanding of the universe's origins and its fundamental nature. These discoveries raise profound questions about the true age and structure of our cosmos. Could the universe be significantly older than previously estimated? Or perhaps our universe is not a singular entity, but part of a vast interconnected web of multiple universes. Another possibility is that the universe has always existed in some form, without a definitive beginning, an eternal cosmic continuum. Given the seemingly infinite expanse of the universe, the notion that it has no starting point becomes an increasingly plausible hypothesis. What we currently perceive as the Big Bang might not have been the absolute beginning of everything, but rather a transformative event within an ongoing, perpetual sequence of cosmic evolution. Instead of a singular origin, the universe may be an eternally existing causal set, continuously evolving through cycles of expansion, contraction, and rebirth. If this is the case, then JWST's discoveries are not just pushing the boundaries of astronomy, but challenging the very framework of our understanding of existence itself. Let's wrap things up. If you've made it to the end of this video, be sure to share your thoughts on these discoveries and your opinions on the age of our universe in the comments below.